don't want us to record the fact that you're in our webinar chat or you're in our attendee list, please do let us know. So without housekeeping out of the way, and the only other housekeeping I normally do is to point out where the escape exits are if there is an issue. I'm not expecting a fire drill here in my house, but if the kids yell very, very loudly, I may have to leave stage right. But all of you should feel free to drift in and out as you feel the need to replenish your stock of beer and food and snacks. But without further ado, Marcus, perhaps if you want to kick off with your deck.
Thank you very much, Paul. Yes, let me share one sec. Actually, that's probably the part I'm most afraid of, but I hope this works now. Can you see my screen?
Yeah, looks good.
Okay, cool. All right, now the topic of the evening is about collaboration in data science, and I personally truly think that this is one of the most underestimated topics in data science, because it's on the one hand so obvious, and on the other hand, for many organizations and projects, it's also a lot you can do wrong. That's why my colleague Yu, who heads the machine learning department here in London, as well as myself, I'm heading the data science department here in London for GfK. We would like to show all of you a little bit on collaboration, also based on what we do at GfK. But it's truly beyond what we do at GfK, and we would try to provide you with really a broader view of why we think collaboration is so important for data science. Maybe before I start, also to phrase about myself. I've been with GfK for more than 12 years in several analytical roles. Started my career in Germany and moved to the UK about 2 years ago, setting up the data science part of the London Tech Hub, as Shirin referred to earlier. So without further ado, why is collaboration so important for data science? And it actually already starts with the term data science. When you look on the job market, if you talk to different people, you will figure out, and I'm sure a lot of people on this call have the same experience, that there are so many different ways to see and look at a data scientist. You have very different roles, from very, very tech-heavy roles to analyst roles to the statistician. Actually, my experience is that many have kind of relabeled themselves, basically calling them the data scientists for very, very different reasons. That's what's happening out there in the market. But in essence, what this means is that we are talking, it's a little bit like talking about ice cream, but not understanding that there are different flavors. So that is actually already where collaboration is so important. When you look at the profile of a data scientist, the very common standard is what you can see here on the screen. A data scientist requires skills in very distinct areas. Statistical skills, mathematical skills to understand the modeling part, technical skills to code and make sure that whatever comes out can be translated into proper code. I mean, in essence, the output of a data science solution is always some kind of code which more or less needs to run into production. And last but not least, also a domain knowledge. So a knowledge about the content the solution is for. So in essence, we have three very, very also very different areas which we need to cover in order to fulfill the purpose of the true data scientist. And as we can already see, this overlap which defines the data scientist is fairly small. In essence, the way I usually put it is that in order to find this, you will need to find this unicorn. So to get experts who are able to have the same expertise in all these three areas, statistical knowledge, coding, as well as domain, is practically impossible to find. I'm not saying there's no one out there, but for many organizations, this is not really the solution. What does this mean then? It actually means that data science per se is already a collaborative approach. And this is also what we do at GfK. One reason why this presentation is done by you and myself. In order to represent the data science function, it's not just me representing it. It's actually me and you together, because the way we understand it at GfK is that we have dedicated specialists in certain areas working together in order to bring data science to life. This is what we call the more statistical focused data scientist. So someone with knowledge on the coding part. It's not saying that there is no coding knowledge, but more knowledge on the statistical side of things, and the more technical focused machine learning engineer. But both roles represent data science, and both together form the data science department. And only machine learning engineer and data scientists working together are able to deliver results which truly see the value and the quality that is needed to serve our clients. So that's already one of the first important takeaways for us as an organization, that there is not one data scientist. It's already within data scientists different roles and different skills that need to be combined in order to bring the power of data science to life. So in essence, what needs to happen is a very close collaboration of different skill sets to make this happen. However, unfortunately, this is not enough. Why? When you look into what data scientists are really focused on, then you can see here on this chart what data scientists love to talk about, what they're doing, what their focus is on in the day-to-day business. It's about data. It's about understanding data, figuring out where they are coming from, and how we can improve this process. It's modeling. It's looking into statistical models. You can see here also neural networks. I mean, deep learning, artificial intelligence. These are buzzwords which you will find all over the place. But then it's also about tooling, of course. I mean, I think most of us on the data science side love to play around with tools on AWS or GCP, Azure, different vendors offering different solutions here, of course. That is our home turf. That's what we're looking at. That's also where we provide our expertise, and where we can truly provide, make a difference. Now, it is a little bit about you're really a true nerd speaking about his passion. The point now is we love to talk about this. We love to focus on this. In reality, when we look into our business, the situation is that people do not really care, or the ones consuming our solutions do not really care too much about that. Usually, the starting point of a data science solution for internal or external clients is a problem. You can see this here on the left. There is someone really pondering about a problem, and trying to figure out a solution. And now it is the job of the data scientist to help bring this to life, to provide value. In essence, a data science solution is only as good as that they can help to provide value and solve a problem. And I want to emphasize this two things here. First of all, data scientist helping, so it's not just a data scientist delivering. And on the other hand, really driving value. And value is usually something which very intuitively helps you solve a question, not necessarily just the output of a model, of looking into the technical details of a statistical solution or a technical solution. Now, bringing this to life, data scientists helping. what does this mean? In essence, it means that we need to think collaboration one step further, really to come up with a value I just described. So this it takes two to tango. That's not enough. We actually need to look at the bigger picture. And the bigger picture here is that we need even more skills to deliver the value I just referred to. We need engineering, front-end engineers, UX people, Q&A, but also dedicated domain experts, here represented by a product owner, in this process to think of a problem as an end-to-end problem. So the starting point is the problem, the end point is the solution, and somewhere in between, and I'm pretty sure as a very important step, is the data science solution. But it's one step, and it requires a collaboration across data science as a function itself. Now, when we're talking about an end-to-end team and cross-functional collaboration, we actually open the next Pandora's box, because this now leads to more challenges. It is necessary to have this cross-functional collaboration, and I truly believe in that kind of collaboration really delivering the true value. However, it is not always a happy family. We combine different skills, we define different people, and we also somewhat combine different languages we speak. We all know this, that the way data scientists talk to each other, the way engineers talk to each other, maybe also the way product or domain experts talk to each other, that this is a certain language they use. Now, cross-functional teams need to go through the very same process. They need to come up with a common understanding of the problem, but also a common understanding to solve it and talk to each other about it. This very, very often leads to conflict. I mean, I think it is fair to say that at least at the beginning of such a process, when you bring together these kind of teams, you will see your fair amount of fights, and it's not just about the regular phase of agile teams, but way more than that. In essence, in an end-to-end team, you at the very beginning, you again have small silos and people in their comfort zone, and we need to take people out of their comfort zone to make this happen. What is very important here is when I say create a common language, we need to make kind of compromises. We need to try and have the willingness to understand each other, and this is and therefore it's important that we build bridges in talking and collaborating with each other by speaking to each other, but also by making sure that we have people in the team who can help us to build these bridges. Now, this is actually a very, very special bridge. So what you see here is the Millennium Bridge in London, and for all non-Londoners, you might know that this bridge has a history, and is actually called the Wobbly Bridge because at the very beginning it had really an issue of being stable when a lot of people crossed this bridge. So actually, after one day of use, the bridge was closed down because it was just not seen as stable enough. And a little bit like this bridge, also then being refactored over 2 years. You can see this as also characteristics of the collaboration process to bring a data science solution to life. It means that we need to work on these bridges. It's not just we build a bridge, it's there, and it stays stable for all eternity. That's not how it works. Bridges need to be tested, bridges need to be refactored, and we need to work hard to establish and maintain these bridges. Now, walking away, going back from bridges to actual people, I would like to hand over to you, our principal machine learning engineer, to give you a better understanding how this bridging can look like. Machine learning engineering for us at GfK is especially important in linking different functions together. And yeah, therefore I'm now handing over to you to explain what machine learning engineering can provide in this process.
Yeah, thank you, Max. Can you see my screen?
Not yet.
Is it now? Can you see my screen?
Yeah, perfect.
Yeah. Hello, everyone. Yeah, thank you very much for attending today's meetup. As Max mentioned, so the term business requirement to working software is not one team or department effort. Is required different of a department and a team to contribute together. And as a machine learning engineer, we have both capability on the modeling and also on the software engineer. So we working as a role as a bridge to connect these teams and departments working together to ensure this process is moving smoothly and efficiently. So we work together with a data scientist to turn those equations and formulas to programmed code and help them to ensure what kind of technique and library package all those information which they need and how to code in the software engineer style and what kind of functional tasks we need to cover or to ensure the model and algorithm is working properly. So when we're talking about the model, data is really important component, and we work closely with the data management team to understand what kind of data available to us, what we can use, what we can do, and also what's the structure of the data, each column and content, what they are representing, what they mean, how good the data which we have, whether the content is fed in frequently and reliable, or there are some missing information. And sometimes we have a multi of different of the resource. So what the different resource means and in which situation, what kind of data we should use. So those kind of information, we all rely on the data management team. So we work closely with them to ensure we use the right information, right data to build our model and provide the most reliable information to our client. Yeah, our product is running on the Google Cloud. So we work closely with Google Cloud engineer to establish the developing environment and also discuss with them and understand what kind of services on the cloud we can use, which one is most suitable for our requirement, and what is the permission, what we can do, what we cannot do there. Also is the architecture of the whole process. So where is the data should stored and where is the code, how the different of the components need to connect it with each other and communicate it with each other. So with all this, we work with a software engineer and to turn all the model and algorithms to the working software delivery to our client. This is not only just a software developing stack, as generally people know, like the software architecture, how the different components link with each other, and how to do the repository management and database connection, test, user interface, communication, continuous integration, those kind of things. That is general topics, which when people talking about software developing, it also involved with algorithm and the model explanation. We choose this way is because we can document all the details about the model and algo which we are using. But sometimes the situation probably is really complex. That can be turned to be a long and tedious science paper. For people, it's not easy and quick to get what it's about, especially for the people who haven't know much of those background. It will be hard to understand. So we worked closely with a software engineer to explain how things works and work together to find the most optimized solution to deliver the stable and reliable application to our client. Yeah, that is a general of overview work which is involved with a machine learning engineer. That's all from me. And we're back to Poland.
Thanks, Hugh. So there was one specific question there for you from one of our attendees, which is, I don't know if you can see it actually, but the question was how you're handling integration and unit testing around the overall machine learning process.
Yeah. So we have our CI build created, and probably is split with two different parts. For the developing, we have a research phase and also have a production phase. During the research, and we worked closely with our product people, and so that is with the research flow. We developing something and get feedback from business people, and when it's all get satisfied and sign off to say, okay, now the model is mature. We work together with a software engineer that is following all the software engineer steps. For example, like test-driven developing and those kind of things. So in that part, the build and the integration is coming into place. So every time we have the test driven to develop all of the production code. Yeah, so it's split into the two parts. You need to put the continuous integration to the research. That probably is not really work. Yeah. Hope I answered the question.
Sorry, I was just going to say as well, there's another question, couple of questions in there. For the benefit of the attendees, what I propose to do with some of these, I think are more general, is we'll save those to the end. Megan, you posed a very good question, but I think that's one that we can come back to and put to the entire panel, if you like. And there is another question there from George Joseph, which is the question of how you handle continuous deployment, continuous integration. Whether or not you use a cloud-based approach or you have something similar, or maybe something which is peculiar to GfK.
Okay, so I suppose this is a question for me as well. Yeah, it will be when it's a turn to the production side, it will be the same as the general software developing, and we have the version control. So when new features is coming in and we add to the current situation, so it will deliver all for the version which is mature and tested and also signed off with the business people. Yeah, we have the tester team as well, and also as Mark mentioned, we work with product owner before it's launched to the client. There is like a UAT environment, and the product people will have a look and say, okay, this looks right, this is fine, and then we deliver that version. Yeah.
Okay, well, there'll be plenty of opportunity for questions a little bit later on. So I think perhaps, Jan, if you can take the floor and show us your presentation. Thank you.
Sure,
Thank you very much, you and Marcus.
Thank you, Paul. And yeah, welcome everyone to my living room. I hope you're all coping somehow with these crazy new times. I'm certainly looking forward to this webinar. Let me just fiddle with the technology to share my screen. Okay. So yeah, hopefully you should see my screen now. So just like fitting for our today's theme, I'm going to talk about collaboration too, and how collaboration is essential to make a data science team part of that 15% success story, because these are the odds of successful data science delivery. It is roughly 15%, which is not great if you think about it. So collaboration is at the heart of these 15% success stories. Just a little bit about me. I'm a data scientist by profession, but I'm at the same time a techie, geek, and innovator with great passion. And as far as my bragging rights go, I guess I had a successful startup which I co-founded with some friends. And AnyChange is now the biggest utility switching portal in Japan. I have a PhD in mathematics. Guess that makes me a smart cookie. I did lead data science teams at Rank and Supla before, but now I'm an independent consultant at the moment with Trainline. So my responsibilities in terms of leading teams obviously isn't that direct any longer, and that also includes how collaboration for me has changed. But I do see now more data science teams and how they work together, which is interesting at the same time. As a millennial, I'm like all over the internet, and I'm craving this attention on social media. So feel free to follow me on LinkedIn, post me questions if you have any. I blog a lot on Medium, and I hope I have some new followers on Medium after the call. Don't make me beg for claps, but I will if I have to. So I like to start with a question to the floor, because I mean I can't really see anyone, so let's try like a digital version of that. Do you feel like data science is a success story from like your personal experience, what you read online, what you hear about the hype, etc., all the big success stories you might have heard, all the kind of massive failures with data breaches you might have heard? What do you think? Is it a success story or not? Just put it in the chat box, yes, no. Let's have a look what people think.
I think you've got your first answer in there with the "it depends."
Yeah.
Yeah.
So, yeah, I mean, you can see it's starting to be like a very mixed set of replies, and actually that's exactly what it is, to be honest. It depends greatly. For the people who are more like skeptical, I mean, I would say data science is a huge success story. We just need to look at companies like Google, Facebook, or Amazon, or GfK. I'm pretty sure they will tell you that they see data science as a massive success to their overall success as a business. I mean, it goes that far that they create entirely free products for us to use just to collect more data. So certainly a huge success story for these companies. At the same time, you start to see like companies like DeepMind, which managed to bring basically things which were in the realm of academic research now into a more commercial setting. I mean, I did my PhD in reinforcement learning. I could have not imagined that anyone would dare to try that in a production commercial setup. I mean, other examples, we know Obama's campaign in 2012. I mean, he's generally referred to as the big data president. The use of analytics in his presidential campaign is basically attributed to a lot of the reason he might have won. And even like the national obsession with the UK with the weather is dependent on a weather forecast, which is just an application of data science. It depends on big amounts of data and simulations. It is basically a form of data science. But then, you know, while this all sounds really great and cheerful, there's the flip side to this coin. The 75% of the business which frequently in surveys report that they struggle with the business adaptation of data science outputs. That basically means that 3/4 of all models are built but never used. That's not great. And I think like when you see surveys which have been conducted over the time, you see that roughly like 85% of all the past big data or data science projects basically were discontinued at some point. So yeah, it's not really looking that great either. So I guess to summarize that with like the more elegant words of William Gibson, the future is already here. It's just not very evenly distributed, or with my more simpler words, making data science a success is actually really, really hard. Let me go back to my presentation. Okay, so why is data science so hard? We already saw in the previous presentations that data science is not only an emerging business function and constantly evolving from ongoing innovation, it's also hugely complex, and there's the obvious kind of collaboration which is required for data science delivery between data scientists and engineering functions, because in the end, models have to be deployed into production. That's a massive engineering challenge. And while I love to talk about the engineering challenges long and lengthily, there's another element to this, and I feel that this is equally important as like the engineering challenges we tend to focus on a lot. And actually, Marcus and you did mention that already, and that is product. And basically product is kind of a buzzword in itself, but at the same time, it is a way of structuring collaborative cross-functional teams around a product owner who basically owns a problem statement from the customer perspective, and that can be an external or internal customer. And product thinking overlapped with data science and engineering to build data science enabled products for customers or users is where the real magic starts to happen. So that's all good and great, but when you think about it, there are a lot of tech companies out there which basically are trying to run data science functions and aren't very successful with it. And they should have it really easy, because not only do they know engineering, for them, the engineering is the product, right? A tech company, a software house, is basically producing technology as their product. So it's interesting to see that they still struggle with data science and the data science success in the kind of value generation. And I guess the question then is, how do you manage a successful data science delivery pipeline? You know, why are even like tech companies struggling to actually deliver data science projects end to end? And as I said, it's one aspect is that it is an emerging business function and still undergoing heavy innovation. But at the same time, these software companies and tech companies tend to run agile software development processes and cycles. And as I will now show you, that can feel a little bit like a square peg in a round hole for data scientists. And the main reason for that is that data science heavily depends on research. It is an essential part to the data science process, but unfortunately, a lot of research doesn't fit very well the agile development cycle software companies or tech companies are actually running. I mean, I like to structure research into 3 categories. There is the kind of long-term research. These are specialized research teams. They tend to work in the high-tech companies like Google and Facebook or DeepMind, and they're not really the kind of typical commercial data scientist, which is the majority of us. Then we have the medium-term research, and that's all about building these scalable foundations where we adopt basically constantly evolving domains within data science to that business-specific context of that company where we work. That's like a medium-term research effort data science functions have to deliver. And then we have short-term research challenges, and that's all around the kind of application-specific challenges and the selection of a good solution design to deliver your data science model. This can be about presentation layers for your data, the correct selection of algorithms, the validation methods and metrics you might want to use in your project. So with this kind of in mind that basically research is this essential part of the data science function, I kind of personally see 2 kind of work streams within data science teams. And it is basically one around building these foundational layers. And that's a very internal responsibility for data science itself. And at the same time, I see that it's very personal to the teams. And it's not really suitable to try to squeeze that into an agile development cycle. It's where you have a lot of proof of concept work with not really defined success criteria and certainly no deadlines usually. And it is therefore best as an internal responsibility for data scientists. But from that foundational layer, we then try to basically scale up a wide range of applications and business use cases. And that's where your project delivery pipeline has a function to play. And that's where we basically take the kind of data science domains which data scientists have adapted to that business-specific context and deliver actual business applications. And you see that there not only are data scientists involved, that's where you then have that team sport between engineering and product. So also to deliver this kind of business application, I like to contrast that to the kind of proof of concept work you see a lot in that foundational layer to a proof of value thinking around the business applications you want to deliver. It is a key sport, and I've seen personally that a main way to coordinate and prioritize this kind of business application delivery is with a proof of value thinking. So I want to just talk about what proof of value thinking is and how that might look like. So in terms of delivering a data science application through a development pipeline is not that much different to traditional software, with the one kind of difference we talked about, which is the research element. So you have these kind of 4 phases, which also you mentioned briefly, of like scoping a project, researching solutions, developing it, and then deploying it. And at the same time, we know that it's kind of a team sport between these 3 functions of engineering, data science, and product. So we have our canvas where we try to basically deliver our business application, and everything needs to begin somewhere. So we need a starting point. And the perfect way to start any kind of business application delivery is with a product need. There should be a clear problem statement from a product perspective. what we're actually trying to solve. Because unfortunately, not many customers or users care much about the data science model and the beautiful scores we might produce. It is all about an actual product need. And taking that product need, the next step is that we shouldn't solutionize, and I've seen that a lot. Product teams tend to solutionize, and that's not really a good idea, because if we are data-driven in our decision process, then we should actually have the ideation as a main responsibility of data science, because they're closer to the data, who would be more suitable in coming up with data-driven and or data-informed ideas how to solve a specific product need. But saying that, the product team has an important role to play here, and that is basically, before you can leave that scoping phase, you need to reach an agreement with product about the scope of the application you try to deliver and the metrics you try to address. And you should use data to predict how much you might move these metrics for that product team, the KPIs they're interested in and they define success by. And if that agreement can't be reached, then there's no point in continuing. If the metrics you want to move with your propensity model don't make enough impact to be worthwhile, then stop there. But if the agreement is reached, then we basically move into that research phase. And that's the short-term research we defined previously, very application specific, just looking at the right way to basically present data, select algorithms, do literature research about previous solutions to your specific problem in how to deploy a model into production, whether you build a batch or a real-time model. And it's important that their engineering plays an important role to sign off the kind of solution design you find in your research efforts for that application, that this is actually feasible to deliver from a tech perspective. And at the same time, you shouldn't leave the research phase before the product team actually validates and confirms that the scope hasn't changed and the metrics are still valid, because you have done your research now, you know more. You should reevaluate whether the metrics you agreed on are still valid. The actual development phase then, again, depends heavily on the support of engineering to set up all these development environments for data scientists to be productive, or manage certain data science platforms, etc. And then you see this back and forth between model development and testing and validating the models data scientists have built, till you have that kind of candidate which looks good enough. And basically good enough is decided again with the collaboration of the product team, checking that the metrics and the scope you agreed in the beginning of the project still hold and the product team is still happy to go forward. If they are, you move into deployment, and deployment depends heavily on the support of engineers. Not many data scientists have that strong engineering background. A lot of this kind of work might exist even in Jupyter notebooks and actually has to be, in the worst case, re-engineered. So certainly can be a massive undertake to deploy models, but it depends heavily on the help of engineering. And deploying a solution into production also requires kind of enterprise requirements like monitoring, etc., of your solution in production. If you have deployed your model, as a last check that, when the model is running and starting to serve customers, that the metrics actually hold in production, because we use historic data to train models. There's no strict guarantee that a model trained on historic data generalizes really well to basically unseen data. So you check that. If everything looks good, you can consider that project delivered. And obviously, that's also not the entire story. I have an entire talk just on data ops, how to check the health of models in production, and how to manage the model lifecycle. That's another massive beast to solve for a successful data science delivery. But there you go. That's basically how proof of value thinking translates into a solution delivery. At the same time, this is a very quick introduction, and I don't go into much detail, I know that. And I mean, this is also very theoretical. Actually implementing this isn't that straightforward. Marcus already referred to the kind of politics and infighting you can see in teams. So collaboration is certainly not something you deliver with a flow diagram like this. But I do write a lot about these things and my experience from previous companies on my Medium blog. And I just hope you have some time and you find something interesting there. Otherwise, just connect with me on LinkedIn. I'm always happy to have a conversation there. And with this, I'm at the end of my presentation.
Thank you for that, Jan. So just a quick question, George. I think the slides will probably be available, but I'll check with the other presenters that they're happy to share those. I didn't see anything that appeared to be confidential in the slides as we went through. And Christina's asked a question here. Where would you put your UX and user research part in the scoping, research, development, deployment cycle? Do you consider this as part of the product?
Yeah, that's a good question. It really depends on what you deliver. As I said, usually data science itself is not the product. It's more like a foundation and enabler to a product you might build. And so the UI and the UX research is usually done as part of that kind of product discovery. And hopefully, you know, with the kind of product need, there are like wireframes for like how an implementation could look like. But like one thing what I've seen in the past is that data science should play a role in this too, because no model is perfect. It's just a prediction. There's no 100% accuracy, and integrating that with something for a user requires certain mitigation of when the model is wrong. And I've built a lot of recommendation systems where they didn't fail to deliver like the impact the company wanted because the model wasn't performing well. It's because the way the recommendations were integrated with like the front end forced the user to basically acknowledge bad recommendations. And that's exactly the problem. Not all recommendations are always relevant. There's no 100% accuracy, and that needs to be considered in the UI and UX design, which a lot of companies forget.
Yeah, maybe to add to that, if I may, I think the UX part is extremely important for data science, and I can only emphasize what Jan just said. Also, because my experience is that we sometimes try to interpret too much into what data science actually can do. I mean, if you look at the whatever third, fourth decimal, then that's probably not the data science value. In many cases, the feedback that also we get from clients is the data science value is not about getting like a 99% accuracy. It's about making a better decision than the way you've done it in the past. And this is sometimes, maybe the model is 70% accurate. Okay, but it's better than rolling a dice. That's where also value lies, and where UX can play a incredibly important part in guiding this. It makes a huge difference whether you show a number or whether you indicate a tendency, and already the tendency can be extremely valuable for clients, and the way this is shown, extremely important.
So loosely related to that, and sort of picking up on this point of collaboration being a central tenet that drives success in data science projects, I'm interested in your views on the way in which you recruit the hearts and minds of the business community, where even for UX type activities, sometimes they're a little bit fatigued with similar questions on other initiatives, and the extent to which they might want to be a willing participant in your collaboration might be a bit of a challenge. How do you go about that? How do you engage them and activate them?
Jan, you want?
Any
Okay. Then I go first. So, so for us in the GfK, UX is basically a part of the product organization. That's something that I would like to emphasize, because it kind of shows the importance as part of a product building process. Also, if you want to really be, as I think, design led, then it's even more important to already start thinking about UX very, very, very early. So I personally have just little experience also in kind of bringing them into the team. But what can I say about collaboration with them and also activating them? I think the important part is basically about really a constant exchange. So I'm not seeing it as, oh well, there is a 30-minute 1-hour session where you throw stuff over the fence and then someone else takes it over and runs. But having really a constant exchange, and the UX people I have the pleasure of working with, they were also really passionate, about making this work. And making this work is also about understanding the problem, understanding the data, making sure that you link this all together. And a little bit like I showed earlier, in piecing things together. This is something where I feel the UX, the personality of a UX person and a data scientist are not so different. So the activation part really to me is about sitting together and basically stimulating each other by exchanging ideas. That to me is a really key point. However, it might not be just about data science and UX to be honest, but just as an example. Yeah.
So I mean, generally, I try to approach that problem from like as much transparency around the work data scientists do to show that we have shared goals, right? And we actually try to solve the same problem just in different ways, and we try to basically make a company successful, deliver value, and that we all basically try to achieve the same kind of goals and shares the same values within this company. And that hopefully means that collaboration shouldn't be that difficult. Unfortunately, that's obviously not the real, always the real case. And to be honest, the main reason I've seen this break down is because integrating data science into a product, which within a company which doesn't have much experience with this, it's a risk. And when product or UI or UX people are resistant to integrating data science, then they basically reject risk. And you should ask what it might be at the company level, culture or KPIs the company uses to benchmark their teams, which prevent people from taking a risk. And that's where even the most transparency has trouble to overcome that. If a company doesn't have a culture and a setup which basically rewards people for taking risk and trying new innovative ideas, then it's really hard to basically deliver that first data science solution for that company. And it is a big part of why so many teams fail, and why the average lifetime of a data scientist in a company is like roughly 18 months. And to be honest, on a personal note, it was a big part of why I decided to become a consultant, because strangely, coming in as an external person, your opinion is valued much more than when you're this head of data science within that big PLC trying to push, and product internally. So yeah, I'm pretty sure we all have been there, and yeah, it's not easy, and there are no silver bullets.
No, I think they're both very, very fair comments. Just a couple of questions. I'm going to try and link one or two of these questions together. So there are a few people here interested in your comments about not necessarily the research process not necessarily fitting well into the agile framework, and a question about how you map that out, how you map that workflow out, and a slightly linked question here about whether or not you prefer the Scrum methodology for the whole soup to nuts process, Jan.
So, I mean, it's the research part which doesn't fit is that kind of midterm research goals of adapting, things which is published in papers to your business context and make these things work for your company, developing this kind of pipelines and tune the models, etc., to that specific business context. And the way I handle that in the past is, it's really, I never saw the kind of benefit in trying to make it conform with like the expectation of the wider business with this kind of very that really strict process of agile and Scrum, etc. But you need to kind of still provide some transparency around what this work stream creates. And that's basically when I started blogging, first internally for the company to basically allow other people to understand what the team has delivered in that time, which wasn't attributed on any Jira or something like that, to basically be very transparent around why you do it and what the progress is and what the output for the business might be. But the actual delivery of that business application, which runs in parallel, it's constant. You just need to constantly assess how much of your time goes to which work stream, is very much part of a Scrum methodology. It has tickets on Jira because you collaborate directly with other functions, and that needs to be well organized, and Jira tickets and Scrum sprints, etc. is a very productive way of doing that.
Yeah, so I can add to that, because this is actually when I said earlier, well, end-to-end teams, and it kind of it might have sounded like, well, it solves everything. It actually doesn't, and one of the reasons is exactly this research bit, which is somewhat different from delivering software. I think it's still. I mean, we can try to find the silver bullet, which, as Jan said, rightly said, does not exist. But we have to acknowledge certain facts. First of all, at the end of a proper data science solution or life cycle, we have something like a working software. What this means is that we need to adhere to certain principles in the software development world. However, I mean, data science is more than software, and I think sometimes organizations forget about this, that it is a difference between a working software and a working data science solution. These are two different things. So to be perfectly honest, that's also what we struggle a little bit at GfK, to find the right balance between research and delivery mode. The way we do this at the moment, though, is still try to keep the connection between engineering and data science as close as possible, and of course also the domain knowledge from product. This means that we believe that the end-to-end teams, which you showed, is the basis of what we do, because this really delivers the value. But there is a need for more fundamental research. Ideally, actually, from my point of view, these are not pure data science teams, but maybe one or two engineers padding that to also make data transformation, data access, more technical tasks, sometimes a little easier. But this really depends on the task at hand, to be perfectly honest. And that's also then referring to one question which was asked That's why we try to build these end-to-end teams based on needs. I mean, ideally, we can make sure that we combine all these functions into one team. They shouldn't be too big. So our experience is that 5 to 8 people in one team is kind of the size you should aim for. I mean, there's always a little bigger, a little smaller, of course. But I mean, you have to give it at some point. What this means is, if you bring 8 people together and you want to cover a very broad range of skills, then there is very little room to add 2, 3, 4, 5 data scientists in this one team. That's simply not possible, and it adds to what you can do as a team. But I mean, that's part of the challenge, and maybe also the art in bringing the right people together at the right time. And I think this is really crucial for the end-to-end team, as well as splitting kind of a more development or deployment focused deployment focus and a research focus.
Thanks for that. I think there's a couple of questions in here as well, I think, that relate to the use of tools, and it'd be interesting to get your perspective on whether collaboration becomes easier with tools, or whether potentially tools become a hindrance or a barrier to effective collaboration.
Marcus, do you want to start telling us a little bit about the tooling?
Yeah, because I want to go with a typical data science answer, which is depends. I guess. I personally think that tools are usually more helpful than they are a hindrance. But of course, you have always the challenge of getting lost in a tool, of spending too much time on figuring out the right tooling. I think it is important to be also effective in selecting and choosing the right tools. Still, I think there is more benefit in using the right support. And when I mean support, it is more than just picking the right teams or selecting the right method of collaboration. It's also about tooling and how you work this. Actually, to be perfectly honest, the current situation that we are all in under lockdown, working together remote, I think shows the need that you have to be very careful in making sure that you use the right technology. I mean, we are now here on a Zoom call. Let's be honest. I'm pretty sure a lot of people out there had no clue at all that Zoom existed even a couple of weeks ago. So finding the right ways in doing the job, also from a tool perspective, is super important. Now today we are in a situation where even I mean, people from very different backgrounds, even small children, are using Zoom to connect with each other. And therefore making smart choices to solve the problem at hand, and meaning solving the problem at hand here is being as efficient as possible, and being able to focus on the job that you need to do.
I mean, I've seen that also this has changed now very rapidly, because when I started with data science, there weren't really tools for that, and now you start to see more and more vendors creating platforms and tools which actually take proper needs and requirements from data scientists into account. The main challenge is that now you have so many of these tools, and a lot of the good ones are created by startups, and big PLCs are hesitant to adopt a tool like that where there's no clear funding, security, etc. around their tooling. So they tend to be more conservative. But this is now changing a lot, and you see companies jumping on digital collaboration tools, because I mean, we basically can't have a face-to-face meeting at the moment. Technology is here to save us. But so at the same time, there is no free lunch. And I've also seen, companies and big vendors coming in, and I love to refer to it as magicware, as if, like a simple tool can fix things like culture, etc. That's not possible either. So yeah, tools are hugely important to increase productivity and to enhance basically the kind of the good things in your data science team and help with knowledge sharing, etc. But it's not, again, that silver bullet which basically fixes maybe like problems with culture or motivation within your team, or suddenly makes everyone, less risk averse, etc. So yeah, tools are hugely important. Thankfully, there's more and more of them now coming out by vendors. And at the same time, you still have to solve your problems the hard way. You can't just buy a software for it, I'm afraid.
Yeah,
Yeah, I
yeah.
mean,
So
I think
it's
sorry, Marcus. I think it's a really good point though about the fact that there's a proliferation of tools out there, and I have a slight concern that you have people who rapidly attach to one tool. And if you use Zoom as an example, a lot of schools in the UK went down the Zoom route, and then there was a security issue that pushed them all away from it rapidly because of the GDPR and the data protection issues with children's data. And then they all ended up going over here, stage left, and started doing something in Microsoft Teams instead. And I wonder whether you see yourselves as having a role in terms of not necessarily being the arbiter of which tool is the best tool, but certainly helping people to understand what the right tools might look like.
Yeah, I mean, I think one of the jobs that we as data science need to do is kind of replace gut feel with a data-driven approach. Maybe replace is a little too strong word, but maybe at least challenge gut feel. By doing this, I think you can support these kind of decisions and make sure that you guide in a way which is based in the numbers. I'm not calling the facts because still, I mean, numbers and facts are two different things. But I think it's definitely a better guidance than just say, okay, well, I think I heard, and this might and should and could. So I think their data science can play a role. However, this does not replace really thoroughly understanding the data. This does not replace thoroughly understanding the problem. And this is actually the danger about the tooling. As Jan rightly said, there are tools and vendors out there, and sometimes that's actually what I'm really scared about. It might sound like, or it might seem like, well, you throw your data into a machine and the machine does some stuff, and then suddenly the problem is solved. I personally believe this is really dangerous if you believe that's the way you should do things. I'm not saying you can ease the process, but believing that there is some machine, at least at the moment, just going and understanding the problem, the data, and then come up with a solution. This is really dangerous.
I think part of the challenge is that a lot of the user community, a lot of the business community are often sold through the sales process on some of these tools on the basis that silver bullet type model of big bucket, fill it with data and you will have answers aplenty, is mis-selling to the business community to the extent that it becomes difficult for you to unpack and unpick that when you're trying to do the right thing with them. Did you have any tips for how you might deal with that? How you educate or guide or facilitate the thinking around assessment of whether a tool is actually fit for purpose for a business?
I think I'm always shocked when companies don't have a proper procurement process and they just sign checks without any proper oversight and challenge of the solution. There are no requirements specified from the business side for that solution which it's supposed to address. And you see that a lot, and it's quite, I mean, I'm quite shocked by that. So yeah, proper process and structure, should be in place before you buy any kind of solution. And then ideally you involve, the stakeholders internally who's supposed to use these tools to take apart, the marketing from the actual, technical solution you will get in the end. And I mean, it really, I guess how you can do that really depends. I was always very fortunate to work in quite big companies with big names, so you could always push them for a free trial, etc. It was very easy to just get something for a while for free, so you can just test it and see whether it delivers. It might be harder if you don't have a big brand name attached to you. But yeah, I don't know, Marcus, any insights?
Yeah, from my point of view, I think it's very important at the very beginning. You should make a clear problem statement. This ties to what you said, Jan, on the procurement process actually, because if you don't understand your problem, your need, then you will definitely fail. Especially in technology, you can easily get into this hype in a certain buzz. Meaning, what I mean by that is, I remember vividly a couple of years back during a conference, I met a couple of guys from another company, and I asked them, yeah, well, this conference here is about big data and big data technology. What are you guys doing here? And they answered, oh well, yeah, our company sent us here because we need to do big data. And I said, okay, do you have a huge amount of data? And they said, no. Then I said, what are you doing here? They said, yeah, well, our boss told us everyone does big data, so we need to do big data too, and therefore we need a big data tool. And I mean, here I think you clearly can see the problem. This is like, oh well, everyone does something, so we need to do this as well. This sounds like, I mean, pick whatever vendor out there. It's a little bit like, okay, everyone does, so we need to do this as well. And this is also a little bit of when we talk about digitizing businesses, at some point to me, it's also sometimes it sounds a little like, yeah, well, now we need to do this. And I'm not saying there is no need, there is a huge need, but we need to do this in a way which makes sense, and which also helps our clients and helps to solve the needs that we have. Just to do something for the sake of doing is never a good solution. And I mean, the same then goes for tools. There is again a big danger that you have so many people and tools, companies approaching you, and of course they will always offer you the best tool ever and the one which solves all your needs. And you need to be careful. If you're just buying for the sake of buying, never a good idea.
Yeah, I love the overwhelming confidence they have that the tool that they have in their bag will solve your problem. Now tell me what your problem is.
Exactly.
Yeah. Can we maybe move on to talk about how you assemble your teams and how you ensure that you've got that right balance of domain expertise and technical expertise? Do you find that there's an exercise in onboarding people which has a sustained necessity to just check that people do get it and they are learning enough, either data science learning about the domain or the domain learning about the capabilities of data science?
So it has obviously changed now for me going into like consultancy. But when I was building teams at Rank and Supla, I mean, it is basically a reality that I end up with more junior data scientists, and actually I started to like hire analysts, product or commercial analysts, because back then, I mean, that's now a while ago. In particular, like people came out of university research backgrounds or also like early data science programs, were taught their like skills in a very academic setting and couldn't actually really deal with the real world messy data companies have, and they completely failed to apply their knowledge because they couldn't write the SQL to get the data. You didn't have that problem with analysts. They knew how to access data, and upskilling them in how to build a simple classifier isn't that hard. The main challenge and something I had to learn is how you, with a team which is fairly junior, you can give them ownership of their problem and the models they try to build, so that they stay motivated, have that sense of purpose, and learn from their experience and learn from their mistakes, and how you safeguard that within a commercial setting. And I tend to call it constraining the artificial stupidity of models. It comes down to like the realization that I mean, machine learning is really capable and really powerful in interpolation of problems, but it is a dangerous thing to use for extrapolation. But you can just do that. You can just like continue to like, if you use a time series forecasting tool to continue to forecast, you know, a week, a year, 10 years. I mean, nothing stops you, right? But at some point you leave that kind of safe space where you actually have representative data during your training phase to make a score or a decision. And that's basically what you need to constrain and put these safeguards in place, so that when basically you try to use your model in a way where it's just not safe to do so, because, you know, there was no data in the training set which is similar to that request which comes in for scoring, etc. You should just not score, and you need to basically pick models and problem statements which have a meaningful business default action, so that data science can just opt out to like score if the model isn't very certain about the score itself. And building these patterns around your team, then you can basically have junior data scientists and analysts learning the ropes of data science with ownership at the same time. And basically the safety net is there that mistakes are not costly for them, for me losing my job, for the business losing a lot of money. But yeah, it's an interesting problem, and it's not that easy to build these teams, but yeah, a lot of them tend to be more on the junior side, and you need to find ways to basically allow them to grow and to learn on the job. And that means a lot of mitigation of potential risks, mistakes, etc.
Yeah, so I think this makes a lot of sense, and I think it's also fair to say that I mean, building a data science team is already probably pretty hard, and building then on top of that with different skill set more on an end-to-end side, it's probably even harder than that. My experience with this is, first of all, we often underestimate that building a team takes time. If you put together a team, the experience, especially in higher management, also stakeholders, they want to see results yesterday. So that's the situation. But putting, and actually then the worst thing is that one of the it's a little like an immediate action point where we say, okay, well, it doesn't work, so we change the team, or we need to add, or we need to replace. But the thing is, I mean, each and every team needs some time to grow together, and also to develop a kind of a common identity. That's just how it is. If you try to replace people, if you try to change things right away, this does not save yourself from exactly requiring to spend this amount of time. So really, time is of essence the first thing. Obviously, I mean, you need to balance skills and also seniority. I mean, the way Jan you put it was a little bit like, okay, well, I have to accept juniors, but I think we all were given chances when we were younger, and growing and helping people develop. For me personally, this is still one of the big privileges I have in my job, to help other people around me grow and see their development, and actually both as people as well as data scientists, also to emphasize this, which actually leads me to another important point here, which is on culture. We can talk about technical tooling, about skill set all day long. If you're not able to provide the right culture and the right environment, a safe environment where you can foster collaboration, where you can make mistakes. Honestly, this is very a very important point, that you need to be allowed to make mistakes. Otherwise, especially in the field of data scientists, if you're not allowed to fail, you will fail as a company or as an organization. So when it comes to bring this all together, this is an art, and to a certain extent, you probably will never get it right, and you shouldn't expect it to get it right. But I think providing the right environment, and also really from a culture and time point of view, if you have the right expectation, I think this sets up on a pretty good path. There's still a lot you can do wrong, and honestly, I'm the first to admit this. I've done a lot of mistakes in this regard in my career, no question about that. But you need to reflect on that. Just taking action again for the sake of taking action will take you nowhere.
Is there a role there for the leadership within the business to set a specific tone about, you mentioned it earlier about taking personal risks and potentially operating on that fail fast model, knowing that you're not going to be hung out to dry if you get it wrong, but it's understood that getting it wrong might actually be a fundamental part of the journey towards getting it right?
100%. Honestly, I mean, we now frame it as getting it wrong, but let's frame it differently. Why not saying, okay, we tried something, it did not work, and we learned something from it. Yeah. I mean, to be honest, this is really a way of how you put it. And if you look at a result, and you actually, if you maybe put it like you have an hypothesis, you test it, and it does not. Well, it just doesn't work, for example, or it says, okay, this hypothesis is wrong. Is this now a failure, or is this just giving you another layer of information which you can use on your next project? I'm very tempted to say it's the latter, because it actually gives you information, and honestly, for some companies, and I would include GfK here, this is actually also a part of the delivery to our clients, or the consultancy business to our clients. Not just delivering products or data or whatever, but if they have a question and something doesn't work out, because we know it doesn't work out, it can lead to tremendous help for consultants, for salespeople, to provide the right guidance, especially, for example, in a situation like the one we are in now, where it's crucial than ever to be very, very careful to not misinterpret what you have at hand.
I think, yeah, when you think about what kind of solution gets picked, right, in the development or the deployment of a model, it is the most promising one. It is where, based on your understanding of a problem, etc., it's your safest bet. And if that goes wrong, that's hugely informative, right? I mean, there's so much to be learned why something which seemed to be the right thing to do didn't work. Usually that means you learn a lot about your customers, things you completely missed before in previous iterations of your products, etc. So yeah, we should overcome that fear of failure. It is certainly not that. It is always an opportunity to learn, and there can be huge value in learning something from something not working.
So just to pick up on a question that was raised by Lakshmi in the Q&A, what's your experience of managing the business's stakeholders, key stakeholders, and people in the business where you may be having to go on that journey where their historical expectations may always have been that you'll just come back almost with a fait accompli, here it is, it works, it does what it needs to do. Whereas with data science, it's a more involved, more engaged role there for them. And as we've heard tonight, collaboration is key to the success of that. What's your experience about managing those stakeholders?
So like a personal kind of admission, I struggled a lot with this. And the reason for that being that as the head of data science in these companies, usually there is not much middle layer, and you tend to report strangely directly into like a CFO or a CPO or a CDO or something like that. And the kind of way how people at the C-suite think about problems in their company is very different to what a data scientist does and how they think about problems, but also the way the C-suite expects communication to look like, down to very specific points, right? And basically a simplification always and to the point, right? Which is really hard with things like data science, where the answer is always, well, it depends, or it's complicated, you know, and communicating with this level is really hard, in particular for data scientists who, you know, might end up in their functions because they're really good in statistics, mathematics, or are good engineers and can get things into production. And suddenly they have to face this kind of C-suite kind of communication barrier. And what I think is a pity is that I haven't seen in my personal experience a lot of C folks coming halfway. And that's, I think, is very much a big, I mean, it's a shame and a missed opportunity, but also then, you know, a reason why it doesn't work. Communicating with the senior stakeholders is very difficult, in particular because data science is a difficult topic. And if there's no meeting halfway on building these bridges, then that's not gonna work.
Yeah, I can only agree to that. The communication with especially the C-suite, I think, is at the moment still pretty hard for data scientists, because although it's a big buzzword, we tend not to have the representative of data science really being in on this level. I think this will take a couple of more years, when also someone like a CTO is someone with a data science background. At the moment, I think there's still a lot with more of an engineering background, and very much focused on the software side of things. Still, I mean, when it comes maybe also to the levels below the C-suite, I think the first and foremost, it's about communicating and making sure people understand what data science is about, and that it's. I mean, this is not a business analyst. This is more than that. There is a bigger part of that than you know, just looking into the figures and coming up with an analysis based on an Excel sheet or something like that. On top of that, my personal experience is that I think sometimes a good idea to also push back and point into the direction of client validation. The reason for this is that when the person you described, Paul, in terms of, you know, someone coming to you and basically they understand the business and all this, there is sometimes a tendency to be the proxy for something's going on outside of the company. Which is not necessarily true, and I'm not trying to argue with the knowledge of these people, but I mean, reality is usually more complicated than that. Meaning that clients are different, and also the feedback that you receive in a direct conversation with a client might be just differently received in the way that you hear completely different things, and also other things that can benefit you from a data science point of view compared to a product person. So actually, that's kind of a kind of, yeah, if you like, recommendation to the whole community. If you sometimes feel pushed too hard, push back, and also ask for direct contact with people and the consumer of your data science solution. If you can do this, then sometimes the conversation really changes, because you get out of this demanding and control loop. I think it's important that data science is perceived as a partner, but this really goes both ways. We as data scientists need also to position ourselves as partners, which is trying to understand the client, and trying to understand the product, and really be also owning our solutions. I think there is no way around this. If we are passive, we will be treated as passive people and functions.
Paul, you're muted.
Sorry, all. I fell off the call when my children decided to use YouTube for 5 minutes. Either that or my Skybox was downloading another random film that I'll never watch. The lessons learned in the past from looking at some of the other areas, related areas, might be useful here, though, because if you look at IT, IT spent 30 years being told what it needed to do before it developed that thick skin and the rich veneer of being able to say, no, we're the experts in this. It is a partnership. We have to come to the table where we both have something to say, and a set of roles and delineation, which means that we are both part of the solution rather than you tell us what we need to do and we go away in a dark room and conjure something up. Do you think that that's a journey that is being mimicked to some extent by data science? For example, how long do you think it will be before we have a reasonably robust cadre of high quality data scientists taking up main board positions?
I can make that really quick from my perspective. I mean, yes, absolutely. We should always learn from the past, right? And data science is nothing which kind of came out of nowhere. I mean, it has a long kind of history of, like, you know, data mining, etc. What as a business function. So there's a lot to be learned. I think my challenge is that that was all very much before my time, and it is very hard for me to learn from that past. You know, I kind of sometimes feel that I have to rediscover all this by repeating these mistakes, just because, you know, all these webinars and meetups and all of this is a new thing. It attracts, unfortunately, younger people, and people with that knowledge and experience, they tend not to be that accessible. So I wish there would be more sharing of knowledge and ways of working from that past kind of learnings of, like, digital transformations of companies, etc. You know, when we all had to, like, adopt mobile first. I mean, you know, it's not that we need to reinvent the wheel here. It's just, how do you access that? That's the main challenge.
Yeah, so to answer your question, Paul, on when will we see data science in higher position, I honestly think it's probably another 5 to 8 years potentially. I don't think it's too far in the future, but there's still a way to go. I mean, it in the end, I think it also really comes down to all of us understanding, as a data science community, that we need to support each other. It's for more experienced people to learn from younger about the latest trends on what's going on. I mean, I can learn so much also talking and interacting with my team, and I hopefully can give something back by guiding and helping also with my experience. And this is so important as in an environment where we are so used to also competing with each other. But in the end, we need to understand that we are in this together, and when we collaborate and learn from each other, there is so much we can gain. And I truly believe there is way more gain in giving than there is the threat of someone taking away my position or money or whatever it is. But in essence, I think it's really about a certain mindset. If you try to compete only, I don't think this will work in the long run.
I think you're quite right. I mean, this concept of collaboration beyond the four walls of your own business, the concept of that term that keeps getting bandied around, co-opetition, cooperating with the competition. If we see what's happened over the course of the last couple of months with what can genuinely be achieved at scale and pace, where people collaborate without fear of competition or without fear of giving away the crown jewels, so much more can be achieved. And there must be so many more prospects of being able to do that without actually compromising your commercial competitiveness. I don't know whether it's the data science community that could lead that, but I certainly feel that the data science community comprises people who, from my own experience, are more likely to do that than in some of the other areas of business. I'd be interested in your view on how you could do more of the same.
Yeah, I mean, I think it goes back to the fact that there are so many different flavors of data scientists, and then that is so hard to really be an expert. I mean, would I consider myself a really a full-blown data science? Probably not, because I mean, I have my strengths and weaknesses. I have to admit it. That's just who I am. Do I consider myself a data scientist? So yes, I do. But it doesn't mean that there is nothing to learn. And it's not like we can walk away and safely know, okay, now if you read this book, if you know that program languages, if you have an expertise in that area, then yeah, you're safe. I think especially in data science, this is not the case. I think we have to live with it, but it's a characteristic of what we are doing. I think we should not just accept it, but I think it's more than that. It is really something where we should be proud of, because it gives us a certain diversity in our field, also on different views. And I think this is then the foundation of growing. We sometimes tend to understand where there is one solution, and this is also something that we learned also from other fields. We're saying, okay, there is a right or wrong answer, and I strongly believe that there are many different, probably very good solutions for a certain problem. Just need to dig deep. What I learned from a great mentor when I picked up leadership, then he said, well, don't start motivating people. They are motivated. They want to do something. Don't demotivate them. And still up to today, this is something that is really key to also my approach to leadership. And when you look at that, then it means everyone can contribute, and usually there is something very valuable to the contribution of each and every team member.
When it comes to the perceived risk of being very transparent and share like learnings and implementation details, etc., within data science, that's actually where there's a big differentiator between data science and software development. If you share your software, anyone can use it. If you share your insights in how you solve the data science problem, it's not that you can just transfer that into any other business context. There's been a lot of work being done to adapt solutions to that specific business context, which can't just be replicated. The solution is highly dependent on your data within your company. It's trained against that historic data. It's unlikely that your competitor has exactly the same data, but it's like in volume, quality, or like specific features. So there's basically, that's why you see also like slowly a culture of sharing and even open sourcing of like frameworks, etc., emerging within data science, and why data science as a discipline stands on the shoulders of a very high quality open source community, because there's actually very little risk from a business and commercial perspective to be very transparent about what you do, how you do it, and even give back to the community with the help of open source, because it is not that easy to replicate the kind of application implementation of your data science.
And allow me to add to that, because I'm really passionate about this. When Jan just said data, this is absolutely right. The point also being that we need to be very careful to understand where data comes from. It's I think it's one of the most underestimated things that we think, well, data is data. It is not. And to all of you out there, it definitely is not. If we don't understand where it comes from, how it was gathered, like when things like that, this is super crucial. It makes a difference if data is collected today or if it was collected 4 weeks ago. And if you don't know that, then you will draw the wrong conclusions. So also, especially with people more from a engineering background, my experience is that sometimes it's really underestimated. That it's not just, oh, yeah, give me the data and I will do something with it. We need to put a lot of effort into understanding this, and this is a genuine task of a data scientist, sometimes really underestimated. And just want to really emphasize this, because I sometimes feel one of the biggest failure is to not trying to understand data properly.
Yeah, according to that 80-20 infamous 80-20 rule, we spend 80% of our time trying to access data and basically curate data before we actually pipe it into modeling.
Yeah.
So a question for you. I suspect this is probably more for Marcus, but Jan, you may have a perspective from when you were previously employed by businesses and building your teams.
I promise
How do you
I
go
certainly have
about?
an opinion.
Yeah, sure, and you know, your opinion will be valid just as much as anybody else's because you will have built teams in the past. But the question that's come up in the Q&A stream is how you go about testing at interview stage the extent to which somebody has those cultural tenets that means they're likely to be a good collaborator rather than somebody who can probably sell you a good story about how they go about collaborating, but probably are quite comfortable sitting internally in the organization and waiting to be fed activities rather than getting their sleeves rolled up and joining in. How do you go about testing that at interview?
So for me, one of the really first and super basic starting points is trying to have really a proper conversation during the first interview stage. What I mean by that is, are you able to walk away from a Q&A testing during the interview into really a conversation? And what I usually find really interesting is to see reactions from candidates, especially when you walk away from the more data science questions. If you talk about, you know, football or whatever, you know, is the weather can weather. You can see if someone is open to a proper conversation, or if this is not possible at all. And I think you will see if you can connect to this person or not. This is now a very wishy-washy answer, I know, but it's more on a feeling. Another important step that I truly believe in is connecting kind of candidates with other team members, and ideally actually also other team members outside of the data science team. Of course, this probably depends on the size of your organization, whether this is possible, but you can learn a lot of putting the candidate in a room together with other team members and just let them have a conversation. Also go out, not you as a hiring manager, go out and then talk to your team about how they perceive the team member. My experience is that you will learn a lot from that. I mean, last but not least, again, as stupid as it sounds, it's a gut feeling. If you have someone in front of you, you can really connect, and you see, well, there is something fishy about the person. Maybe the answers were just, it was sometimes something wasn't right. Your gut will tell you something about this. But in general, I think if you look into these three areas, that's from my experience actually, I feel you can. You will be able to detect a lot in general. Also, I think one a recommendation from my end to hiring managers is not to kind of overthink too much. What I mean by that is, I mean, you can go crazy and, oh, I have now 5 candidates and what can I do? And especially in the data science market today, Charlie actually taught me was, if you're not quick, you will lose people. So you need to be thorough, but also you need to be quick in your decision making. And that's why, I mean, think about this. But if you have a positive feeling about this, if the reaction in the interviews is positive, if your team is actually coming along pretty well with the candidate, then you should be in a pretty good position.
So it's always refreshing to hear a data scientist tell you that there are occasions when you don't rely on fact and logic, you rely on chemistry and gut.
I'm sorry to say, but that's kind of important too. So it's not always there. But actually, it's really more on the cultural side of things where I feel my sure. point is, and that's important.
So I like to second that, because when I had to build teams, usually there was some form of technical screening before an interview stage. So people who reached that level, that bar, and basically made it to the interview, they kind of have proven to some degree that they have technical knowledge. And then the interviews I did didn't really do much more than trying to find out whether this person is passionate about what they do, whether, you know, what they learned from mistakes in the past, and trying to find that chemistry and just see, you know, whether this person is motivated, understands the way of how you want to work as a team. But at the same time, I think that's like something I became more aware like later on, is like how important it is to hire for diversity, and where, you know, hiring by chemistry can be a problematic approach, because you tend to hire people you like because they're like you, and that can be dangerous, in particular in data science. I mean, there are so many really good examples, right? I mean, the last one, which was quite big, is, you know, Apple's credit card. I'm pretty sure that no one at Apple was sitting around the table and thought, you know, what would be really, really good, like goes down really well with our customers, a racist credit card, you know. But we tend to test solutions internally, you know, dog fooding it, etc. And if you don't have the diversity, you might miss things. It's not that anyone, you know, wanted that. It's just an oversight. And having, you know, such a complex business function like data science, which depends on collaboration between so many different skill sets coming together, it is really important to just allow for the diversity and find an interview process where it doesn't depend too much on their technical skills, because you can always upskill people, right? And you need to give them the opportunity to grow in their role. That's important for culture and motivation. And you need to find a way to not just hire people you personally get along really well, because they tend to be very similar to you. I mean, I stopped doing interviews alone and was asking, for example, product owners to sit in and basically actually also lead at least half of the interview, just to basically break it up a little bit and avoid having this kind of one hiring manager, you know, making that decision. And that really helped, not necessarily, you know, by not having a mishire. Sometimes that happens, you know, and the question is, how do you address that? And it's a complete other conversation. But in terms of like recruiting and interviewing, it's very much around, you know, people's motivation, their values, etc. But you should find a way to ensure that you allow for diversity in your hiring pipeline.
I wrote a paper 25 years ago for the United Nations, which was titled, a very, very formal paper, but it was titled, "Hire Crazy People. For God's sake, hire crazy people and hire them now." And it was this concept of trying to find a recruitment strategy and a recruitment model where you didn't hire people you liked, you hired people who could get the job done, but created a more diverse work environment. The problem is that people desperately try hard in the interview process to be like the person the other side of the table, because the academic world often prepares them for those interviews on the basis that you should be mirroring, you should be building a bond, you should be trying to find some shared goals, common vision, and common ground. And often that just confuses those scenarios. So often my feeling is that that process needs to be lengthened ever so slightly, albeit, as Marcus has pointed out, maybe done on a condensed time cycle, but nevertheless lengthened and turned outwards so that you involve other members of the team. You maybe use social settings as much as work settings. You maybe bring people into a meetup where there's one or two beers and a bit of pizza, just to see that they haven't got two heads and speak a completely different language, and maybe their common lexicon isn't quite as common as yours. But there's no right or wrong answer with this from my perspective. So I think your comments are valid. Boiling it all down and distilling it might be quite difficult. If you had your time all over again and you went out to find a firm to work for, what do you think you'd be looking at from a candidate perspective? And what do you think the difference might be in terms of looking at a small organization where there may be limited prospects of getting the degree of collaboration you would thrive on, versus going to a larger organization where inherently collaboration should have a better prospect of being part of the corporate toolkit?
What I can only advise data scientists or aspiring data scientists is to not be shy in the interview, to ask pointed questions. There's no point in, believing what you're told about, their amazing data infrastructure, their amazing culture, their amazing knowledge sharing and growth opportunities, if it all is just marketing. Because, in particular in the data science space, it's a sales job on both sides, right? There's much more demand than supply of talent. So companies tend to lay on quite thick there. And you should look under the covers and ask these pointed questions and ask about what's important to you. If you are an early stage data scientist and you want to be sure that you can learn from someone, ask whether they, who's the senior in your team. Do they have a buddy system where you can get mentored or something like that, right? If you're more senior and you just want to avoid all the politics, then ask, how they solve that and how they want to manage risk in the business, etc. And you should just ask these questions.
Yeah, absolutely. I mean, to be honest, I think the times are long gone that we are talking about interviews and hiring. And actually, this is more like a speed dating. I mean, and actually, this is about fit on both sides, and we should acknowledge this. This is not just about a candidate coming to you; it's also about you as the hiring manager, as a company. Yeah, kind of applying to the candidate as well. That's how it is, and we should acknowledge that. To add to Jan's point, actually, I think everyone should also ask about weaknesses and areas to improve for each and every company. If there's no weakness, if there's nothing to improve, walk away, because that's simply a lie. Because then we are exactly the point that Jan just mentioned, where it's all hiring, it's all great and marketing. This is not about the free coffee. This is not about the free food, and this is not about the table tennis and whatever. This is stuff that, I mean, I'm not saying everyone is offering, but it needs to be more than that. So there needs to be a fit. I mean, in tendency, I'd say for a younger data science, potentially it might be easier in a larger organization, because it might be easier to find people to mentor. But this is not trying to take anything away from smaller organizations. I think each and every one needs to see if you are more the type of person who needs more guidance, or would like to have guidance, then maybe the large organization is better. But if you are the person who wants to learn more tasks, more as having more responsibilities and being broad in the task, then a smaller organization is absolutely okay. So I think it's super hard to say, well, this is the one way to go. But in essence, really being also clear yourself on what you want. I think this is important, and don't be shy to state this, because there is no point in rushing into something. This is a little like going for the third, fourth best option of beer or whatever. You will not like it. You should try to maximize it. I mean, at some point, of course, there might be some shortcuts or maybe also some compromise you need to take, whatever. But yeah, that would be my point. To be very, very clear on what you want.
Yeah. I'm conscious of time, and I'm also conscious of the clapping for the NHS, which is taking place literally, I think, as we speak.
Yep.
All I want to do at this point, I think we've covered most of the questions. If there are other questions, please email us in. You can email Mike or myself, or I think any of the panelists, and we'll do our best to answer those. But thank you all very much for speaking tonight. Thank you all for your fantastic answers and your contribution. Hopefully everybody who's here and attending found that useful. And in the meantime, I think probably making for the front door and putting a round of applause in for the NHS. But Charlie, do you have anything you want to add?
No, thank you, Paul. I think it's been a great event. I mirror your sentiment there, and of course, I think we should clap for the NHS.
Yeah.
Let's do this.
Thanks very much to everyone who attended. Great event. Thanks everyone. Paul, Marcus, you, Jan, Charlie. Sharon. That's been brilliant. Thanks very much.
Yeah, thanks everyone for attending.
Thank you, everyone.
See you, everyone.
Thanks.
Thank
See you
you.
all soon. Stay safe, everyone.
Yes, bye.
Bye.